we can quickly brush over again the slides that we have for week 3, and then we can open it up for discussions, right? And I have my iPad here, but there's not too much writing this time because it's more of just concepts. So let us quickly go over those. So Mohan, yeah, your certificate is here, so it works. All right. So in week 3, what we look at is the real world, right? So week 2 was theoretical. We looked at backprop. We looked at how to, do the optimization. We looked at gradient descent. And then week 3 is about actually getting something to work. So for example, your week 3 assignment is interesting. We create a RAG application on SIGGRAPH papers and host it on Railway or one of these platforms. And to do that, we obviously start with a pre-trained network. So, there is this myth that we need a lot of data to train. Usually, when you're, for example, doing your RAG for week 3, you will not train. You will just use forward prop. So you would use a pre-trained network. You can call an API, you can run it locally. In our case, we'll call an API. So what does it mean, transfer learning? It means that, okay, you have a network trained on a lot of data. Let's say ImageNet data. So ImageNet is uh, a million images, training images. And let's say now you want to fine tune on your data, maybe indoor scenes, maybe, inside your apartment, something like that. So that can be your data. And the usual workflow is that you start with fine tuning. Even when you train detectors, you use like a backbone pre-trained somewhere. You might use a ResNet 18 backbone, you might use a Dino V3 backbone, you might use so all these are names of backbones. And we cover this in week 4 when we talk about architectures. So you will take any architecture. This is the oldest architecture, the AlexNet. And you see, this was a simple CNN. CNNs also we start to touch upon already in week 3 and then week 4. And then what you want to do is you want to simply remove the last layer, right? So this is the layer where you have trainable parameters. In the softmax, there is no trainable parameter. It just exists to make your output into a distribution, to make it peakier, right? So that you can then apply cross-entropy loss on top of that. So the idea is to simply remove this and swap it with just one linear layer. So all you're doing is putting this new W matrix on top of your 4096. So the size of your weight matrix will be something like 4096 cross whatever number of outputs you have now. Initially, it was 4096 cross 1000 because there were 1000 classes in the ImageNet model, but now it will depend on what your new data looks like. If you have more data, you can fine tune parts of the network. You can fine tune the whole network. It depends on what you want to do. Uh, and like it's like just a single line. For example, this was Keras, also in PyTorch. You can load pre-trained models. For example, in this case, we load MobileNet, and it also says include top false, meaning you're not including this classification layer, right? And then all you have to do is add. So you have to, add another layer on top of that. You have to concatenate a layer, and then your mobile net is ready to be trained. One rule of thumb is when you're now fine tuning, you have to fine tune with a very low learning rate. You have to fine tune it with, let's say, 1/10 or even 1/100th of the original learning rate, right? Because you don't want it to diverge. You don't want it to learn too much. And another very important thing that you should notice, whatever normalization they used in the original image, right? You have to do that because that is the range of numbers the model is used to see, right? Used to seeing. Because suppose you were doing zero mean dividing by standard deviation, then your numbers would be, around the minus 3.0 to plus 3.0 range. So you have to do the same normalization again with your input now, just so that the network doesn't see a completely different distribution and get confused, because then it wouldn't know what to do with those numbers, right? And that's it. So you have these 4 cases. You have very little data, you have enough data. It's a very similar data set. It's a very different data set compared to, let's say, the ImageNet data set. When you have very little data and a very similar data set, okay, fine tune just the last layer, fine tune more layers if you have more data. If it's a very different data set, then obviously you're in trouble. So, all bets are off, and you have to see what you can do. For example, start with a modern backbone, such as a Dino V3, because Dino V3 is trained on hundreds of millions of images, right? So it can generalize pretty well because it has seen almost all kinds of images. Uh, Again, transfer learning is pervasive. It's a norm, not an exception. For example, when you train on object detector, the baseline, so in the case of faster RCNN, there was a base CNN which is already trained. When you do image captioning, again, it's trained. Even when we do modern detectors, it's usually so, or almost all the times we start with, something pre-trained. So Siddesh recently trained a detector. It got very good numbers, and even he was starting you. So data will always be lesser than hundreds of millions of images. If you have that kind of data and compute, please, more power to you. You can train your own network. But the goal here is to stand on the shoulders of giants who have done a lot of hard work before us, and we want to, because of that, we want to use these pre-trained models. um, I think he ended up using Dino V3 as the backbone. Siddesh, what other backbones did you experiment with before uh, homing in into Dino V3?
I think it was Dino V3 only, and before that, I used SPDOLO, which uses CNN backbone.
Yeah. So the CNN backbone again comes from some existing model. It can be a ResNet 18, a ResNet 52. It depends. There was also a VIT backbone, which was trained by Google, which is also very common, and that is also a backbone that you can look at. So that's it, right? So that's all about transfer learning. Now we talk about your assignment for the week, which is very interesting in my opinion. And what we do is, and we talk about this in a lot more detail later, but this is just to kind of give you an intuition. What we want to do is we want to embed your data point, be it a document, be it, so be it an image, be it a speech. In this case, we work only with documents, and there are these three documents which look different. So those three should give us these three different embeddings. So what we want to do is we want to represent our document, our data point using an embedding. And an embedding is essentially a vector, a lower dimensional vector as compared to my original input. My original input, let's say images, it's easy to explain because images, let's say you have 100 cross 100 pixels, then total you will have 10,000 pixels, right? But then you can still represent that 10,000 pixels using, let's say, 100 numbers, right? And this 100 numbers are your embedding, are your latent representation, right? Is basically the vector that represents your original input. And then what you want to do is so in the RAG use case, you want to retrieve, let's say, you want to first embed all of them into some space. Obviously, you cannot visualize if it's more than, you know, uh, three dimensions. So here we're just showing it for didactic purposes. But then what you want to do is, okay, you've embedded and the vectors look like this. And then now you get a query document. Again compute its embedding. And then you find the nearest neighbors, around that vector. And that just means that these are answers which are related to my document, which are similar in the dot product sense. So a question would be similar to its answer because that is how the LLM is trained in the SFT step, etc. And then you just retrieve those, and then you retrieve the corresponding chunks, the corresponding text blocks corresponding to these vector embeddings, and then you can stuff it into the context of an LLM and give your prompt, and that will generate your final answer. So retrieval happens here, and then generation happens using your LLM. And this is the assignment for week 3, and you'll have all the support, and it's pretty straightforward. Then we talk about babysitting, and I'm not gonna, go over babysitting. We can talk about it, but it's essentially something that you would do throughout the course, turning the hyperparameters, right? Tuning the knobs. How do we get to the best hyperparameters? Then we speak a little bit about, all these different interesting things, and I don't want to spoil it for you. If you have looked at it, then we can, and then we talk about these different parts. So cross entropy, we did not differentiate by hand. We did not create the Jacobian and the gradients, and we do that here. Similarly, we talk about a little bit of other loss functions and so on. So this is basically a very quick overview of what we've done in what will do in week 3, or what some of you have done in week 3. But now over to you. So what I want to do is ask you guys what you've been thinking about, and we have like 45 minutes for discussions because last time we didn't have enough time because we were talking about like backprop. So yeah. So over to you guys. Let's open it up for questions, for thoughts, anything that's going on in your head.
Hey, hi Arjun, Pratim here.
Hi, Pratham.
So I have a question.
Yes, of course.
So far we have discussed about loss. Now this mean square error loss we have not discussed much, right?
Yeah.
So for mean square error loss, do we apply the same kind of backprop and all the similar kind of formula, or it is something
Absolutely.
different?
Yeah. So the concept of backprop doesn't change, right? You need the chain rule. I mean, I'm sure you know differentiation. So when in differentiation you have, variables that you want to differentiate later, you need to do the chain rule to bring the gradients to the previous layer. So be it mean square laws, be it any laws, the same principles apply.
Okay, and you have mentioned that mean square error loss is more applicable for some continuous parameter. And,
Yes. Yeah. So mean
so
square
can you
laws.
explain a little bit more, like why it is like this?
Yeah. So I mean, what do you think? What does it mean, continuous parameter? So what I claim is that if you have a continuous output, if you
Yeah.
have regression, if you want a real number as output, your cross entropy will not work, and mean
Yeah,
square error is the loss that you should be using.
yeah. And like why it is like this?
Yeah. So what do you think? Do you have any thoughts? Like any guesses?
Maybe due to the how it is defined, right? The mathematical definition.
Yeah.
That
So
is
for example, how would you even apply cross
square
entropy?
root.
No, no. Let's talk about first cross entropy, and let's talk about applying cross entropy to a continuous output. So cross entropy, how can you even apply to this? Can
Yeah,
you?
cross entropy actually it is either correct or wrong. That kind of
Yeah, but
either one and zero.
suppose I want to get an output between 1 to 100, right? Real numbers, 1 to 100, it can be 1.4, 1.8, 10.9, whatever. So now if I
Yeah.
want to apply cross entropy on it, what would I need to do? I'm claiming there is a way to apply, but what would I need to do? Think about it.
Yeah,
Like,
we'll use the same mathematical framework actually.
no,
Whatever
no,
we
how will you do
discussed.
it? Because now I want numbers between 1 to 100, but cross entropy can only output a class. It doesn't know about the numbers. It's a one hot vector.
Yeah, correct.
Hmm.
100 vector, either 1 and 0. So
Yeah,
that
so
is the
it is
one
just the negative log of the correct class, which is the
correct
output, which
plus.
is the loss. Yeah.
Yeah.
So how will you apply cross entropy in this case where I want to get a number between 1 to 100?
Yeah, I will not be able to apply it.
There's a way to apply it. Think of what you can do if you were to apply cross entropy, and then you'll very quickly see the downside of that. Anyone else?
Using a range or something like bucket type.
Sorry, what? Anish?
Maybe you can create a bucket of like 10 or 5 and like something like that and compare with the same categorical thing only, but with the
Exactly.
range.
Great idea. Perfect. And it will work. So what Ankit just said, sorry, who said
Okay.
that, Anish? Yeah. Is what you can do is you can, for example, divide this 1 to 100 into 10 buckets, right? And then you have 10 classes, 1 to 10, 10 to 20, 20 to 30, 30 to 40, 90 to 100. And now you will get a class. So now you can say, okay, as long as my output is within, uh, if my output is 13, I want the second bucket to be the answer. If my output is 99, I want the last bucket to be the answer. But this is very coarse grain. So then you can do fine grain. So then you can have 100 classes, but then you're still not getting like 13.6 and 18.9.
Yeah.
So for that, you can do 1,000 classes, but then you're still not getting, the 0.001s. So then you can do 10,000 classes, but then you are wasting a lot of parameters, and classification becomes hard because you need to then have balanced classes. But when you want just a number, a mean square error is actually more meaningful because it exactly wants your output to be that number. It will penalize it if it is not that number. So you can apply cross entropy, but mean square error is a better thing to do because you want exactly that number. When you want to do classification, you don't care about the actual output. All you want is the correct class. You want to know the arc max of your vector. You really care about the output, right? You don't care about the max of that vector, which actually gives you the confidence of the class of the output, but it is not calibrated. You should not believe in that confidence, but it gives you a small indication.
Okay, got it. Okay, thanks.
Cool. Thanks, Pratim. Good question. Okay, Satyamurthy has also joined. Hi, Satyamurthy. Welcome.
Yeah, hi, Arjun. Sorry for being late.
No problem. How are you doing in terms of, let me also open my dashboard.
Yeah, so I'm yet to finish this second week assignment, but I
Okay.
finished 4 videos in third week. So just to be in context,
Yeah, that's great. Well done. And I see that you've also attempted the assignment. So that's again very commendable. So if you need help, let us know. The TAs will be able to help. I'll be able to help. But
sure, sure.
yeah,
Yeah,
but
no,
it's great.
not.
Yeah, good progress. Anyone else I did not see? Okay. Oh, Sharath is also joined. Hi, Sharath. Yeah, Sharath has also done half of week 2. I think you were also asking for AI tools, and I think the emails must have gone out this weekend with all the tools that uh, you need. I think we're giving you Claude, we're giving you Gemini, we're giving you GPT. I think I don't remember, but I think you'll have access to Claude Code also, like anti-gravity, windsurf, whatever you're using. Look, like Cloud Code is probably, and because with your subscription, you're able to use Cloud Code, so I recommend using Cloud Code.
Yeah.
Yeah, great. Yeah, we can continue. Charit, how about you? Like, you have any doubts, any questions, any comments, advice?
No. I got through the TA session in the morning today, 7 a.m. one, and got the cloud installed and integrated to Devin as well. And I understand assignment 2 is still just to be done just hand and mind, basically, so that yeah, I was.
No problem. I think your voice is not like the microphone has an issue, but anyways, but no problem. Yeah, all the best. I think week 2 is really the watershed moment. Like, it's the hardest in my opinion. And once you cross week 2, I think things get easier. It's also a little bit more high level after that.
I had one question.
Yes.
For week 1, I would say
Yes.
you had said that loss will always be a scalar.
Yes.
But in this age of, we do have functionality to do multi-objective optimization. So why it helps definitely to have it as a scalar. Everything else is complicated enough in multi-dimensional. But is that the main reason to keep loss as the final simple?
So there are some exceptions. There is the Pareto laws. There are some things, but again, you have to define rules. But the whole point is, how do you choose between two models if it's not a single number? So I have one model which is giving me one loss, one model which is giving me another loss. Which one is better? How do you define that? So that's the only reason we have a. So 99% of the times you will have a scalar loss. This is the Pareto. There is other fancy losses, but people don't really use it as much. Or there are like then rules. Okay, if the first component is greater by 70%, the second one is only weight 30%. But these are again then finally coming down to one parameter.
Got it. Yeah.
Cool. What about other people?
So I have one question on this, basically.
Yes, hi Ankit.
So I've not gone through the week 3 lectures. I've only completed assignment till week 2. But I
Well
have
done.
questions regarding the embeddings. So I mean, I have just a practical question that, for example, I am building a rack system,
Hmm.
and in that rack, the purpose of that rack system is to fetch the revenue data from the annual reports of the companies.
Mm-hmm.
I don't know the companies, what kind of companies I have,
Mm-hmm.
but let's say everything is in English. Okay, so
Mm-hmm.
I've got that kind of a data. So my question is that, okay, so not every company reports the revenue in a same way in their annual report. Like, it could be in a different section, it could be hidden somewhere else, right? So my question is basically, while training my model, how do I uh, build the embeddings so that it is very effective? Also, when my model is trained, when I input my like the companies like for which I want to fetch this revenue data very precisely, in what way I pass on those, in what way I create those embeddings so that it fetches the data very precisely.
Yeah. So if I understand your question correctly, you're saying you have multi-page documents, maybe 100 pages, and that report contains a few pages with financial data.
Yes,
Yeah, something like that. Okay.
yes,
Yeah.
yes.
I will give you my answer, but anyone else wants to go first? How about the TAs? Dipin, you've been doing this a lot. Harsh, Sudesh. Dipin, you wanna take a stab at
Come
it? Like,
again, Arjun. I just had to go attend to something for a short moment.
no worries. So what Ankit is saying is he has company ka like yearly annual reports, and those annual reports have a few pages with financial information, but
Mhm.
it can vary. Some companies may have it upfront, some may have it, later. So how can he identify just those financial informations from those pages, like from those documents? How can he pull those financial information out?
Oh, like one way that I could think of is semantic search, right? Like you that you basically embed them in such a way, and then you kind of query against that, like embedding, and then you retrieve that particular financial data that you want.
Yeah, so that's definitely the way to do it. But one step you forgot, right? You also have to do the chunking.
Oh yeah, chunking. Yeah, if it's a lot of documents, then you have to chunk
No, no,
and
even that one document. So we want to
okay,
find in that one document where is the financial data. So Ankit,
okay,
Dipin mentioned, like if you're using APIs, then you don't need to do this, right? Because what you can do is you can divide that document into logical pieces, let's say one page or half a page, and then pass each of them to an LLM and ask the LLM, is this financial information? Is this financial information? The other way to do it is you again chunk your documents, and then for a few of those documents, let's say 10 of them, you pick up the parts manually, you pick up the chunks, and then you say, okay, if it is this chunk, I want it's financial information. So then you embed all of them using some embedding model, using again, so an LLM is an embedding model, and you then remember that, okay, these embeddings belong to financial stuff. And then every new embedding that you get, which is close to the financial stuff, you go and look back, where is this embedding coming from? And the hope is that it will be financial information because it's getting embedded in a similar space. So that's how you would build your system.
Okay. So while training, I would still have to pass the entire document as an embedding, like
No,
after checking it.
your,
Yeah.
your, your LLM is not capable of understanding the entire document because it has a limited context. So you want to chunk it, and chunking is essentially breaking it, right? So you may break it at the paragraph level, at the page level, and you would usually want to do a sliding window, meaning you would want to have some overlap because you don't want to have those boundaries very, very crisp, right? So that's what you would do.
Okay. Okay. And one more question, like related
Yes.
question. So if I'm solving a problem like this, is it necessary for me to use a paid APIs? Like, I mean, can this be achieved using Q1 or some these kind of
Absolutely. Yeah. They're very powerful. Like, if you have a computer that runs a Quen model, absolutely go for it. Actually, that reminds me, like, I'm very so because what you're talking about is an embedding model, right? So whenever you're in doubt, you should go to Hugging Face. embedding models, and then you would see like a leaderboard. So, I mean, that's the best way to actually, yeah, see it. So there are all these different models, and you will also find a leaderboard. So this is the scientific way of doing it, because you actually are looking at numbers before choosing, yeah, so arenas, etc. Right? So, but then again, like it becomes messy. Which leaderboard do you look at? Which one do you believe? But at least look at something before. Yeah. So this MTEB is a very well-known one. This is, yeah, but our current, yeah, this is, so there are lots of these leaderboards. Yeah, for this is a good one, right? So look at this leaderboard. So obviously you have all your expensive models. Kimi K3 is a very big model, so you still cannot run it locally. But then as you go down, so this is a big one, right? 3.8 max. So I think it's a huge model. But then you go down, go down, go down, and then at some point you will start to see much smaller models, right? And so this is still pretty big actually. So they're not showing you smaller model, but there are, so our favorite one currently is this Z-Bench model, Z-Bench embedding models. So they're pretty good and they're pretty small. So, okay, it's there here somewhere. No, it's not. Okay. Um, and then the other one is the Voyager models, Voyage model. Yeah, this one, right? So this is again like a very high quality model in my opinion. So yeah, absolutely. Like these Quen type of 3 billion models, you can easily run on your MacBook Pro or something like that, or even a smart GPU. Yeah. Did I answer your question, Ankit?
Yeah.
Yeah. Great.
So,
Awesome.
so yeah, one more question. Basically, so I mean, this discussion we had in our first TA session. So I had this doubt. I mean, the RAG is still a deterministic, a probabilistic model, right? I mean, it is not deterministic in nature. We are just limiting the context of the.
It's pretty deterministic because, like the embedding bit is deterministic. And once you have the embeddings, then everything is deterministic. There is no probability here.
Okay. So why this doubt? Basically, I mean, I was just looking around. So basically, there are companies which are working in the banking industry in the compliance space, and the compliance basically is something which a regulator gives as a guideline, right? Like you cannot bend around it. So these compliance OS or compliance AI companies basically they must be building some RAG system which gets specifically trained on the guidelines by the regulators, for example RBI or SEBI, something like that, for something like that. So on these documents it gets trained. So my doubt was this, that if RAG is a probabilistic in nature, even though we are limiting the context, whether we will be able to come up with a specific answer or not, like but since you're saying that it's a
Yeah,
pretty much
but
deterministic.
no. So the retrieval part is deterministic because you know exactly which vector we will find, which is the closest vector to this, all of that. But then what will you do? You will take the chunks and then you will stuff it into the context of your LLM, and then the LLM will generate something. So the G of your RAG, right? And that is not deterministic because that has temperature, that has a mixture of experts, that will generate different outputs based on different times of the day, right? Depends on what is the state, what is the initialization, etc. So the generation part is not deterministic.
Okay,
That's
and it will
probably
also depend on the input token, like what kind of question, like if I'm asking the same
the
question in a
prompt.
more
Yes.
convoluted way. Yeah.
Yeah, it'll depend on that exact prompt, the exact question that you've asked. So an LLM has only three things, right? I mean, it has the context, it has the prompt, and it has the answer. And actually, it is these three, the triplet, the context, prompt, and answer is what you also train it on. The SFT step is, we'll talk about this in week 8, but yeah, so it'll also depend on the prompt, on the question.
Okay. So in that case, isn't it a bit risky to build a system which is inferential in nature? Like for example, if I want to build a system which helps me to infer something from these kind of document. But then
Yeah, absolutely. So, I mean, we do, rags. So, but if you do it right, it can be done. For example, so we have a rag for legal reasoning, right? And we're doing very well here. We're doing better than Lagora, LexisNexis, etc. So imagine if you can build a rag for legal, because you can have like jail time, you can have a lot of repercussions if you give a wrong answer. So legal is probably as difficult as finance. But yes, there is a probability of error. But then what is the harness around it? How do you verify the answer? How do you have the pinpoint references? So, but then it's still not guaranteed that it'll be 100% perfect. So then the human has to actually check it. So yeah, it can be risky, especially in your line of business.
Okay, understood.
Awesome. Hi, Harini. I see you unmuted yourself. What's up?
Yeah. Hi, Arjun. So one
Hi.
of the questions I had was that in my area, I'm trying to kind of like provide context in tuning control systems. And so I wanted to ask if there are any embedded or pre-trained models that are used currently to provide context. Because what I do right now, or rather trying to do, is use reinforcement learning to use the pre collected data that I have to provide context to tune like a PID or an MPC controller.
Very cool.
But yeah,
But
so I was just wondering if if there are models like this, then I can give a broader context and sometimes help tune these, because it's a very trial and error basis, and it would be an interesting problem.
So if I understand you correctly, you're looking at like LLMs or VLMs, which will run on an embedded system. Is that what you're after? And then it'll give you
Yeah.
context based on the, yeah, or sorry.
So yeah, something along those lines, like for example, right now where we are trying to retrieve context based on images and text from already pre-trained LLMs, right? So in my context, yeah, there might be some research that it can pull up when I use normal LLMs, but the ones that might have already been trained on particular robotics, or areas where these models are trained on tuning controllers, they would provide a better context than rather focusing on other information, and maybe they have to be even more fine-tuned, and might not work for my case that I have.
Yeah, so I mean, I'll find out more on this, but I haven't used, deep learning for the PID for model control. But I'm very curious. So, for example, what we have used is,
Yeah.
let's say, VLAs, vision language action models, and in VLAs, what happens is your input is, let's say, vision. It can be, let's say, your three cameras and maybe some history. And based on that, it has to give some output, like the next waypoint, or it has to give like the next action, turn right 30 degrees, 90 degrees, etc. But we're kind of trying to reuse the LLM backbone here, and we're calling it a VLA, which is essentially giving action as output instead of just text. But I mean, I would love to understand your world better. So I'm sorry for my ignorance, but can you explain like what kind of context you want from a model? What are you doing now? And what inputs does your PID controller takes, and what is the output context? Is it like text? Is it embedding? What is it?
Yeah, for sure. Let me actually take a simple example, right? Like,
Thank you.
yeah, for example, if in a chemical process, you have a particular temperature that you want a plant to reach, and you have certain variable parameters in that would be, boiling point of your chemical, or things like that can be controlled by us, and maybe a amount of chemicals being combined, etc. So now if in this context, and you have like a disturbance, say you have some kind of a leak in the system, or a temperature, in the monitoring of the temperature, there is some disturbance, so you want to kind of make sure that the temperature point of your chemical remains same regardless of your disturbances as well as your changes in your inputs. And now this is one context of a chemical plant. Now, similarly, if I'm doing that for some other process or for even a simple control of an AC in your
HVAC system.
home, yeah. So any of this requires you to look at the inputs, disturbance rejection, and then maintain your steady output. That's what any controller
Understood.
does. Right? And so PID is used for, it can be used for nonlinear systems, but something like a more sophisticated, like a model predictive control, uses a model to do the prediction and then controls it. This is basically like instead of using black box models, we try to build a physical equation for systems that we already know. We develop like a, sorry, what do you call that? A ODE, so a differential equation which represents the system, and then we do that based on that. So what I'm trying to understand is like there are a lot of control systems out there in the world, and I know a lot of people have spent decades actually trying to tune them to the most efficient way possible. Now that we have those models, or maybe I don't know if it exists, or maybe it could be one of my I could try it as a project. I was actually trying to run it by Harsh as well in the TA session to see if this would be a good capstone.
So, so first question, the MPC controller that you spoke about, you're trying to model the universe of whatever it is, and is the assumption that you'll be able to model it faithfully with your ODEs? Like you will account for every friction, everything that you have in this universe?
That's actually a good question. So, for some cases, yes, it has worked. It is not 100% faithful, but yet it works in a practical setting. Now, since we are having the luxury of data and better use of data, we are trying to move across to not just using fixed ODEs. We try to use data that we can collect in either
Got
through
it.
machine learning or
Got
through
it.
system identification. So even in my area where behavioral health is like a clinical trial is a thing where we collect data from actual patients, we try to use that. And it's still very noisy. There are short data sets, so there are a lot of shortcomings to it because a controller needs stable and a very reliable data set to work on.
Yeah.
And so that's where I thought maybe giving more context, which is maybe not completely related to what your topic is, but having mapping the input and output dynamics, right? That could teach a lot to a controller compared to just using only data for that particular context.
Yeah, but I'm curious, like, how will you use context within your MPC or within your PID controller? But on those lines, so you've heard of world models, right? And what Jan is talking about are these action conditioned world models. So
Okay.
what it essentially is essentially a world model. So assume you're in some state, right? And this world model, what it is capable of predicting the next state given the action. And then what Jan is saying is, okay, you have a list of like maybe 5 discrete number of actions. So what you want to do is you want to check your states. So which state you will be in given the action. So you have 5 actions, A1 to A5. You are in state 1. And now when you apply, so what is your S1 given A1, S1 given A2, and you will get, different output states. And then you keep doing that. And based on that, you can then stitch a coherent path through that. Of course, it's very expensive. It gets exponential very quickly. But then you're saying, okay, you'll have like a shorter window and so on. And this is still very researchy, right? I mean, he raised $1 billion on this idea. But I don't know, like how far this is. I mean, this is the JEPA world. We'll talk about it later. We have again like Siddesh here, who's like really interested in doing this kind of work. But yeah, but these are more of like VLAs, which I spoke about. There's the world model. So maybe more on this in the future, right? I think a lot of people are interested in world models, and together maybe we can all learn and build something real, which will, I think, give us real understanding. Siddesh, do you want to add anything here?
No, I think nothing else.
Yeah. Okay.
Right.
So, yeah, like it's robotics is a similar world which she's talking about, be it a plant, be it an HVAC system, be it like the health data. So robotics is where, and as you all know, there's a lot of money coming into physical AI, into robotics, and I think it'll benefit models such as these that you're talking about, RNA. So I'm sorry, I don't have like a very proper answer for you, but next week, hopefully, together we will all like learn. And
Yeah,
I
no,
will try and like, yeah, find things which relate to what you're trying to do. But I'm still not like clear, like what kind of context do you have in mind? How will you put that into your controller, for example?
Okay, so for example, the what I'm trying to find the context for is the dynamic relationship between input and output, and then the error feedback mechanism, right? So how do you minimize the error given a context, given say, a particular amount of deviations of your input variable and a particular amount of disturbance, and this is what you want in your output? You can easily measure the error, right? And then
Yes.
given the error context, how would you adjust your inputs based on that? So that's what a controller looks at. And I think this context is varied for different scenarios in terms of the magnitude or values, etc. But either ways, we do standardize it. So we should be able to provide context regardless of what the system is or the problem is my thought process. But actually maybe I can formulate this better and try to figure. I did not know about this particular kind of word model that you talked about, so I can try to maybe look into that and come up with.
I mean, even before you do that, just write down
Yeah.
your problem statement and share it with us. I
Sure.
would love to look at it. For example, will the context be a vector? Will it be a blob of text? Probably it'll just be a vector, right? So you're like encoding your context into some vector.
Yeah, I think a vector would be a better input to the system.
What else can you do? Like you cannot just have
Yeah,
blob.
you can't give exactly. Yeah, that's right. I mean, I haven't thought about how exactly I would use the context, but I was just first wondering if this is even there out there.
But not that I know of, but I will also do more digging. But yeah, there are like,
Yeah.
yeah, and we should start with something very simple, right? Like just call an LLM and like start something where you know what the output should be, how you want to tune it, and see if this context is actually helping. But I like the idea. I like the direction. I think there is something there. It's
Okay.
actually, I think, a research problem, not something which is already solved.
Okay. Okay.
Cool.
That's yeah.
Yeah,
Thank you.
you can write a paper on that, I'm sure.
Yeah.
Cool. That was a very good one. Anyone else?
Arjun, hi, Kunal here.
Hi, Kunal.
I was doing the assignment, sorry, the quiz. I was doing the quiz, and there was a question like, if our model is giving the training accuracy as 94% or something, and the validation is showing like 65 or something, then there is a problem of overfitting. So, is there any like rule of thumb or any kind of like the like how do we predict or how do we understand that this is the problem of overfitting?
Yeah, great question. Anyone wants to answer this? Like he's asking if there's a rule of thumb. How do you know 65 to 95 is overfitting, but 85 to 95 is not? So, Kunal, unfortunately, there's no rule of thumb. It's just that 65 to 94 seems like a huge distance, and you will not know it is overfitting until you, let's say, employ some overfitting mitigation strategies. The first thing I would do is reduce the model size or add a L2 regularizer or increase the difficulty of data. And with that, what should happen is the distance between the training and the validation should reduce. If it doesn't, it means that there is some other artifact in data and you're not able to get better. But if you're able to get better, that means that your previous model was overfitting. So it's just like big and small, and it's very difficult to define what big and small is. But here it sounds like a big gap, and this is why we believe it's overfitting.
Okay, so we need to just go through trial and error in the loop
Yeah,
to.
yeah. Everything is like hyperparameter validation, trial and errors mostly. And this is why you need like GPU farms to run. So, I mean, we faced this problem, right? Like our server was like overworked and down a little bit because we were running that small competition, and people were like completely hogging the GPU because they were trying those different iterations, different hyperparameter settings. And like some of them then won the competition because the hyperparameters came out on the top.
Okay, thank you.
Thanks for the question, Kunal. Oh, Pratik has joined us. Hi, Pratik. How are you doing?
Yes. So I'm still trying the week two assignment. I just started
Okay,
with that. Yeah. Uh,
great.
I am having to go through the videos like twice or thrice to completely understand it. So
Okay.
yeah,
Yeah.
things are
But
going. I'm learning something. Yeah.
yeah, but like before going through, the videos twice or thrice, try to do the assignment, right? And then
Hmm.
wherever you get stuck in the assignment, go look at that part of the video instead of looking at the whole video again.
Okay. Okay.
Yeah,
Yeah.
and then we're
Understood.
here, like join the TA session, but next week try to like be up to date in terms of your assignment.
Hmm. Hmm. Yeah. Yeah.
All the best.
Hi Arjun, I have a query.
Yes. Hi, who's this one? Yeah, hi.
Mohan, yeah.
Yeah.
So, so, so far we have seen full of supervised learning. So we have this ground truth and everything. And in real world, it's not possible that we will have ground truth for every inputs. So in that case, how will we formulate our loss function? How will
Yeah,
we predict?
so start with ground truth. Start with annotation. That is what we sell to companies, right? We say, like, see, we will come in with our models, we'll come with everything, but we will start with your data. Currently, you don't even have ground truth data. You don't even know what you're sitting on. So we will start with that. We will create a flywheel to do model in the loop data annotation, which means we will start with a baseline model. We will run it on your data. We will see where our model makes mistakes. We will only take those parts. It's a completely different question on how do you know your model is making mistakes when you don't have ground truth data. We can talk about that, but then we figure out how the model, where the model is making mistakes. We annotate just those, and then we improve our model with that, right? So ground truth is what you have to start with. If you don't have it, you have to find clever ways of getting there. Now I just said, okay, we will try and find where the model makes mistakes. Any ideas, anyone? Like how can you know that your model is making a mistake when you don't have the ground truth? Like try to get creative, try to think autonomous driving.
So I have come across some terms like clustering. So based on the data, so it will cluster those inputs into various clusters.
Yes, that is something you can do. So, and then you can just label the clusters and then you have your ground truth, but then your clusters may not be very tight, so your ground truth may not be 100% correct, but at least it's a start. But then let's ask a concrete question, right? Suppose we're doing autonomous driving. We're on the road. Obviously, we haven't labeled the entire universe, and now the car is making mistakes. How can the car know that it is making a mistake without ground truth? I'll give you some hints, right? The car has a lot of sensors. The car can be driving autonomously, but sometimes the driver has to take over the job of driving the car. So, with these hints, do you have ideas on how can you know if the model is making mistakes?
So
Yeah,
is it like the ground truth is a bunch of rules of real life? Like when the sensor detects 2 meters, then that's a ground truth that you cannot.
No, ground truth is just means absolute truth. It means that you know exactly what is happening in the scene. And the whole point is that, okay, because you're driving somewhere where you've never been, right? So then how can the car still know if it is making a mistake or if it is correct?
Human
Yeah.
intervention, the driver has to.
Yeah, great, Vivek. So
Uh,
if the driver is having to take over the car if the driver, it's called an engagement. So if the driver has to engage with the car, that clearly means that you should collect that data because something weird is going on, right? Why did the driver take over the car when the autopilot was on? So that is one. But can you think of something else?
Like
Arjun, could
the
I?
surrounding is behaving something strangely.
Sorry, what?
The surrounding of the car is like behaving strange.
What does it
That
mean?
can be the
Seeing ghosts?
like let's suppose the people are just getting moving like weirdly around the car.
What does it mean? Like, give me an algorithm. Tell me what code will I write so that so that we know. Dipin, you were saying?
Yeah, Arjun. So I was thinking on the lines that we kind of try to model the average or, like uh, through a longer course of time, how does the autonomous driving works? And if there's any deviation from how it's
No,
moving.
it cannot, right? I
No.
mean, if you could do that, then you don't have to train a model. Then you
Yeah,
could just run
fair
that
enough.
model on the car.
Right.
It's
Yeah.
a very
So
simple
we
answer.
have to
Yeah,
we
go
Maybe
have to
ahead.
depend on other sensors as well.
Yeah.
So we can't really much on AI. So we have to depend on other sensors as well. So based on that, we will take a call.
No, the other sensor also running AI on it, right? Like all sensors, there will be some AI on top of that. The sensors are just giving you measurements of photons or some, voltage difference.
like if there are multiple sensors, if they disagrees with each other, then
Exactly,
it,
Harsh. So that is
yeah,
called the variance.
yeah,
The variance if the variance is high, meaning if the sensors don't agree. So one sensor is saying there's a car, the other is saying there's a horse, the third
yeah,
one is saying there is a, human. So then that's definitely interesting data to collect because what's going on? Why are my sensors going crazy? Why are they not agreeing with each other? So that means there is high uncertainty because there is high variance. So that is definitely data which we have low confidence on. Yeah.
yeah.
What else can we do?
We can have physical non-negotiable constraints like okay,
Absolutely. Well done, Adish. For example,
nothing comes under 2 meters of range.
yeah, exactly. So this is also people. So these are some, in some sense, unit tests for, let's say, vision tasks. So what you can do is you can mark. So because you know the camera level and you know that, this part of the image will always be, let's say, more than 9 meters. So if there's a human detected in that area, it means that, there's a flying human and that's something weird going on. Or the other way around, if the road is detecting again on top, or if the sky and vegetation is detected at the area, because you know your camera parameters. So these are called intrinsics. A camera is defined by intrinsic parameters, which are the parameters of the camera itself, which means the principal point, the focus, the size of the pixels, etc. And then the extrinsics, meaning how is the camera with respect to the origin of the scene? Where is it mounted? So what are the translation and rotation components of the camera? So you know all of that in the car. You definitely know the intrinsics, and because you know the intrinsics, you know that it cannot violate these rules. And these are the only three things that you can do. Driver engagement, variance of your data, and some hand-coded rules to kind of know if it is wrong or right? If this is data worth collecting, if you're doing this model in the loop, which you would want to. So all modern machine learning projects, you have to do this model in the loop for data collection because there is no other way, right? And there's no reason why you should not be doing that. So for example, if it's about LLMs, if it's about creating data for what Ankit was talking about, I would take three LLMs, right? I would take Quen, Kimi, GPT, three very different LLMs, and I would ask each of them, dude, is this financial data? If all of them agree, my assumption would be that they're not agreeing on the same wrong thing, right? Because if it's wrong, if it's like, so that's highly unlikely. But if all the three say something very different, that means I'm not sure about that. There's high uncertainty, and I should take that out and manually label it, right? So that is how you should set up your data flywheel for any project.
Yeah, yeah.
Yeah. All right. Good. Any other questions?
One question I have. So
Yes. Yeah.
I didn't understand. Um, so the the activation functions when used as max 0, x, like
Mm-hmm.
two straight lines,
Mm-hmm.
how it is adding non-linearity, it's not clear to me.
Yeah, the first thing is max of 0, x linear function or a non-linear function?
It's a non-linear, but at least it has two straight lines, like
Yes.
integrated.
Yes, it has two straight lines, right? So now, have you seen that example that I show in my in the video? The mm, the three lines, like
Yeah. So the green dots and
the red dots, yeah. So with that, it's still not clear.
No, I mean like it is just a curve like V, like straight
Yeah,
line, but
yeah.
it is
So
not
no, but
non-linear.
it's a V. So V is not a straight line anymore, right? Now V has a corner. And now if you have many of them, you can carve out like a very complicated space.
Okay.
But I'll send you a paper. Amina, please remind me to find that paper. I have it somewhere. So that kind of explains better how you can come up with these arbitrarily complex hyperplanes with these ReLU kind of non-linearities.
Sure, I'll do that.
Yeah,
Okay, thank you.
good question.
So actually along the same lines, I had another question. So in the using the activation function, right? I actually went and read about this concatenated ReLU just so that to see if using negative gradients would help. Just want to understand if that is something which is used in day-to-day practice or if it's too data
No, great.
intensive.
No, great question, Arnie. I don't know about concatenated, but for example, there is leaky ReLU or parameterized ReLU. So leaky ReLU is where you allow a little bit of the gradient to pass, maybe 0.01 or alpha times, so it's not max of 0, x, it's max of, let's say, alpha x, x. So what happens? And you actually need that. For example, with a GAN, generative adversarial network, gradient is already very sparse, and we'll talk about it in week 7. Why? Because you're coming in from the discriminator into the generator, and the discriminator only knows yes or no. So the generator gives you an image, it gives you a story, and you're only saying yes or no, right? So it's a very sparse signal. And when you bring those gradients into the generator from the discriminator, it kind of vanishes. And there you need to use these and even like modern transformers, right? Like Swiglu or diffusion model. So Swiglu is very common, and Swiglu is again a function where you do not completely cut off the gradient in the negative region, where you still let it pass. Let me share my screen for a second. And Swiglu is a very funny paper. I don't know if you know about it.
Yeah, actually, I think you have in the video it
In
was
the-
tagged. I didn't go through it completely, but it did write that it was written that I forgot what was written,
Yeah,
but
I mean the exact words. Let me bring it up. I think Swiglu. Yeah, I think it's this one. No? Yeah, this one. So Swiglu, I don't think he shows the plot. But what's funny about this paper is, uh,
yeah, we offer no explanation as to
yeah, where is it?
right at the conclusions. The last line.
Oh yeah, so this one is funny, right? So we offer no
Yeah.
explanation as to why these architectures seem to work. We attribute their success above all else to divine benevolence, as all else to So
Yeah.
so yeah, I mean, and Swiglu looks like this. So let me show you. Wait, just Yeah, it looks like this, right? So you see there's this bump, and it's actually not monotonically increasing anymore. So that's actually wrong if you go by just theory. But a lot of things seem to work, which, in practice, which may not really work in theory. I mean, which may not be right by theory. So yeah, Swiglu is one such function. And what I was talking about is
Leaky ReLU.
Yeah. So leaky ReLU, you see, it lets a little bit of this pass through.
Right. Okay.
Yeah. So like I was saying, like 0.001 x, x.
Okay.
Cool. Yeah, good question. Anyone
Arjun, I
else?
have another query.
Yes, Mohan.
This is regarding GAN. So basically,
This
we
is
are
regarding
feeding
the,
the noise
sorry?
GAN, generative adversarial network.
Okay.
So basically, we are feeding the noise and we are generating the image, right?
Mm-hmm.
So after training, how do we know that during inference we are again going to pass the noise and we are going to generate an image? Now, how do we know that for this noise, this is how the generator is going to come
No, we
up with
don't.
an
So the
image?
whole point is that we are mapping a low dimensional, let's say, noise distribution to a high dimensional output. And the whole point is that you can, so this is like a vanilla GAN where you don't have a condition. So you can give it any input and it'll give you some output. Let's say we have trained a GAN for faces. So you'll give it some random input and it'll give you one face. But now let's say you want like a face of a middle-aged man with like white hair. So for that, you would have to give a condition. So you have to encode your condition into a vector and you have to also train it like that so that when you give it this additional condition, it understands what kind of a output it should create. So they are then called conditional GANs, which is in the second part of that week.
Okay, so I mean, there is no use of by only relying on the vanilla GAN. So we need to go with
I mean,
conditional.
depends what you want, right? If you just want faces of humans, then it works. But if you want specific things, then you also need to give it additional. So you need to encode your condition as a vector and then also pass that in.
Okay, okay.
Cool. All right, if you have nothing else, then I'll take your leave. I mean, time just flew by. Didn't even realize it. I really, it's awesome. And please, try and catch up, especially people who still haven't done week 2 assignment. Week 2 is the hardest. If you do that, then the going will be smooth, and the maximum drop-offs happen in week 2, as per the statistics that we have over the last 4 cohorts. So all the best, and if you can, pass this hill, then hopefully going forward, it'll be not as difficult. So it's front loaded, but it needs to be done. So let's, put our heads down, get it over with. And yeah, and then hopefully we'll enjoy this course together. So all the best. And I hope to see you next week. Thank you so much.